No disturbance in classes. Online digital lessons with HD quality transmissions. Subject experts and experienced faculty. Unlike other app, we have our own teachers for assuring 100% quality education. If you too want our quality teachings are at your premises and institutions, not only SSC, but other various courses are in easy method covering state syllabus. We successfully taught at pre-examination period to government SSC students in COVID pandemic. We made grand success our online teachings at private colleges also. Why are you waiting? Just dial for online admissions. Rush and join in ABC Education Learning app.
Hi, good evening. This is K. Parvatisham. I have an experience of 10 years in teaching physical science. You're watching ABC Education and Learning app. So, in the last classes, we have completed the reflection and the properties of related to the light, such as rectilinear propagation. At the same time, we have completed what is the meaning of a reflection. At the same time, we also pursued a few types of images and what are the types of rays which we are executing in the optics. So, let us be back to our topic, that is nothing but types of images. So, in the previous session, we have an advantage, that is nothing but three type of classifications we have discussed. So, the leftover portion as a result of yesterday's class is only one thing, that is virtual image. That is virtual image. Yesterday, I mentioned you a statement. What is that? Virtual image is obtained as a secondary, not a primary. It is not a primary thing because every object or every image tries for a what? Real image, not the virtual image. If real image is not obtained, then it can be covered with a virtual image. So, this is a very important aspect. How? Let us understand few type of rays. Listen, let us be back with our favorite diagram. This is the most favorite diagram because every time since the first class we were drawing the same. So what about this? Is nothing but pole. This is nothing but focus. This is nothing but center of curvature. And of course, this stands for principal axis. So, while coming to this one, I have placed an object here. Listen to me very carefully. What type of rays are we expecting here? Listen, I am able to take a ray which is parallel. Yesterday we have discussed this topic. How many type of rays are there? There are 4 type of rays. A ray parallel to principal axis, a ray anti-parallel to principal axis, at the same time a ray passing through the pole, a ray passing only through the center of curvature. These are the 4 type of rays which we execute in optics. So listen carefully here. First, a ray has been spotted. For suppose it has entered like this. Why this goes in this manner, we will discuss in the rules. Yesterday also I said the same. The very next topic after the virtual image is the rules. So if suppose what is happening, a ray is passing like this. This is towards the pole. This is towards the pole. So what is happening here? If suppose, this is not a criteria, I want you to let when the virtual image comes, Because of that, I am just modifying the diagram, but this is not a actual criteria. So what about, let us understand this ray has been deviated like this. Let us understand the ray has been deviated like this. So as per our knowledge, these two, likely A comma B, are parallel rays, like what about rails of a train? They never meet at a point. So these two rays, when they don't meet at a point, how can you conclude an image? We cannot obtain an image. When two rays are not joining, when two rays are parallel, you cannot expect an image. But there is a small exemption. What is that exemption? You observe me. I just would like to explain with respect to convex diagram. So I am erasing the total portion here. So listen, we would like to take an example of a convex diagram here. Let us suppose. For suppose, this could be your principal axis. This could be your principal axis. And suppose what is going to happen if we obtain an image. This is nothing but an optically active site. But the behind a mirror is not an optical active site. Optically, it is inactive. So what is going to happen if image is formed behind a mirror? In such situations, it can be recognized as a virtual image. If image is formed behind a mirror, it can be identified as a virtual image. It is not formed by the, remember this point carefully, it is not formed by the union of reflected rays. So it is formed behind the mirror. How it is formed? Let us understand the rules first, then you understand this formation very clearly. Let us understand the rules, because the ray has to travel in what the direction, in what the way it has to travel, that you must have an idea. Without that, if I draw the figure like this, in what way does it come? You will get a confusion and you may not get the concept. So I am just explaining you, a virtual image is formed when behind an optically inactive surface, that's a behind a mirror, and it is not formed by the union of rays. It's not formed by the union of a reflected rays. It's not formed by the intersection of reflected rays. So these are the three types of classifications. Among them, we have studied 7 types of images. We have studied 7 types of images. What are the 7 types of images? For suppose, magnified, equal sized, diminished, belong to size. Erect, inverted, belong to position. Real, virtual, belongs to nature of an image. So overall, there are 7 types of images which we are going to expect in the ray diagrams, and these are classified by the 3 classifications. Now, the most important heart and soul of the first lesson, is a ray diagrams. In order to understand the ray diagrams, we have to know the rules for drawing the ray diagrams. So let us go for the rules. Before that, let us understand a small 1 mark question. Let us understand a 1 mark question, very bit minute question. So my dear students, let us be back to our topic. That is nothing but we have to understand the relation between few terms. What are they? The terms are nothing but relation between R. What do you understand by R? Radius of curvature. And F. What is F? It's not MRF, it's just RF. It's not RF. It is capital R and small f. That is nothing but what is this? Relationship between radius of curvature and a focal length. So how are we going to? Again, let us draw our favorite figure. Pole, focus, center of curvature, principal axis. Let us take into the consideration. See, this pole is a fixed point. The pole is a fixed point. And remember, the distance between pole to center of curvature is referred as radius of curvature. It's already known for us. And it is an important point that focus is a midpoint. Focus is the midpoint. So we can make a small equation. What is that? PC is equal to P to F plus F to C. We can divide a line. That is, PC is resolved into PF and otherwise PF plus FC. So automatically what is going to happen? We already know that the distance between pole to focus is called as focal length. Is called as a focal length. Here comes a twist. If PF is equal to F, if PF is equal to F, what about FC? Just think a logic, a small logic. This F is a midpoint, automatically P to F is a F, then what might be the FC? It also become F. It also become a F. How? If suppose the distance between P to C is some 10 centimeters. What I am saying? F is nothing but a midpoint I am saying. When F is a midpoint, it is 5 centimeter. Automatically the other will be 5 centimeter because it's a midpoint. Thus, we are also equalizing FC is equal to F. Therefore, PF is equal to F plus FC is equal to F. Already we know that the distance between pole to center of curvature is R. That is, R is equal to F plus F. That implies R is equal to 2F. This is a relation between radius of curvature and focal length. There is a relationship between radius of curvature and a focal length. You can also rewrite the equation. How can you rewrite the equation? F is equal to, send this to this side, R by 2. According to the need-based situations, according to the data given in the problems, according to the situational problem solving, you can use either this formula or this formula. And of course, this relationship can be asked for 1 mark question. It's a minute bit question. Of course, it can also be asked for bit question, or the problem based on this can also be asked for a bit question. Do not get any type of confusion. It's very simple. PC is resolved into PF plus FC. Automatically, PC has been given R, that is because it's a radius of curvature. PF is nothing but focal length. As it is a F is a midpoint, F2C is nothing but a small f. So, we are able to add the 2F. So, we are able to obtain the R is equal to 2F. This gives us a relationship between radius of curvature and focal length. And of course, this is a 1 mark or half mark bit question. Right. So let us go for the next topic, that is rules of a ray diagram. So let us be back for the topic. Listen, every institution, every situation, every organization makes some rules. You have to come by this time, you have to go by that time, you have to wear this in uniform, and you have to study well. Such a type of rules have been possessed by each and every institution. The same manner, in order to draw a ray diagrams, we are formulating some rules. Those rules, what are they? How are they useful? Now we are going to implement that. Listen very carefully. This is nothing but a rules of ray diagram. You see, we are able to expect rules of a ray diagram. First of all, we can, in your textbook, listen my dear friends, in your textbook, it is somewhat complicated. So, for the sake of benefit of students, our channel is going to simplify and give you a memory map type of view. So, listen carefully. It is nothing but we have been solved. Concave mirror has 4 rules. Concave mirror has been resolved into 4 rules. Whereas for the convex, we have resolved into 3 rules. We have only resolved into 3 rules. So let us study one by one what is the 4 rules and what are the 3 rules for concave and convex mirrors. Listen very carefully. First of all, let us study for concave mirror. So, listen carefully about this one. Here, I am able to take our favorite figure, the concave mirror. And of course, this is also our favorite line. That is nothing but pole point. This is nothing but principal axis. There is nothing but a principal axis. So what is going to happen here? We are able to expect a focus. We are able to expect a center of curvature. We are able to expect the focus. We are able to expect a center of curvature. Let us come for first type of ray which we discussed yesterday. That is nothing but parallel ray. The light ray which is passing parallel to the principal axis. If suppose first light ray comes with a parallel nature, what happens to that? Naturally it should passes across the focus. The light ray which is passing parallel to the principal axis must pass through the focus in anti-parallel manner. This is rule 1. If suppose a light ray is passing parallel to the principal axis, what is happening? The light ray is supposed to bend into anti-parallel, and the condition is it has to pass through the focus. This is a condition which we must remember. So this comes for a rule 1. This comes for your rule 1. So my dear friends, let me repeat a rule once. It's simple thing, very simple thing. What is that? If for suppose a light ray is passing parallel to the principal axis, must and should deviate through the focus. Must and should deviate through the focus in anti-parallel nature. This is rule 1. Then let us study about a second type, second rule. So, you listen carefully. We are moving on to the second rule. And the second rule is quite opposite to the rule 1. Quite opposite to the rule 1. How it is opposite? How it is? Just let me check it. Let us go on for rule 2. See here, let me consider again the same diagram. Let me consider again a principal axis. This is pole, this is principal axis. This is focus, this is center of curvature. Let us suppose, what is going to happen if a light ray is traveling anti-parallel. If a light ray is traveling anti-parallel, what happens for that? An anti-parallel light ray. What happens to that? It's a very simple statement. It travels parallel to the principal axis. It travels parallel to principal axis. Did you come across? Rule number 1 is opposite to rule number 2. In the rule number 1, parallel ray comes and goes in anti-parallel. But here, anti-parallel ray comes, goes in parallel nature. This is the rule 2. Let us again discuss the rule 3. So listen carefully. Rule 3 we are going to discuss. What is a rule 3? See, unlike this one, it is exhibiting some different strategy. This is principal axis, this is pole, this is focus, this is center of curvature. Till this time we have discussed that a ray parallel, a ray anti-parallel. But the third type of ray we have to consider, this is nothing but a ray pointed towards a pole. A ray pointed towards a pole. It doesn't attain any parallel nature. It doesn't attain any type of anti-parallel nature. But what happens to this one? It just gets reflected. It just get a reflection, like the plane mirror. It just get a reflection. So you can understand one concept. Out of total mirror, which point is held for plane type of reflection is nothing but a pole. Here, the other points are able to express parallel to anti-parallel or anti-parallel to parallel type of conversions. But here, there are no such type of conversions. Directly, the ray reflects. And you can expect the angles also. They are obtained equally. You can expect the angles also equally. That is, angle of incidence, angle of reflection type of phenomenon can be seen at a pole. So this is the rule 3. So once, let me recall this one. Rule 2. An anti-parallel ray that must be passed through the focus. Remember this. That must be passed through the focus. Must be travelled parallel to the principal axis. must be travel parallel to the principal axis. While coming to your next, the ray which is traveling towards a pole. The ray which is traveling towards a pole, what it is going to have? It is going to reflect unlike the other. Unlike the other. So, the last type of rule which we see in a concave mirror, we are going to expect now. Listen. So, listen carefully. We are moving on to the last type of a rule that is seen in a concave mirror. Till now we did not start any convex mirror. We have only taken what? Concave mirror. This is concave mirror. Rule 4. The last rule in a concave mirror. You see, let us suppose, again our favorite diagram, that's a concave. Again this is pole, focus, center of curvature. And of course this term is referred as principal axis. Might be, you could have an idea that always, if you see this figure, you might have known with this is pole, this is focus, this is center of curvature, because in this chapter, this diagram, we will get that many number of times. So, it completely discusses about spherical mirrors, so we are able to expect this figure number of times, one more time. So what about this? Here, the fourth type of ray we are able to expect is, if any type of a ray is expected passing on the center of curvature, if any type of ray is expected passing on the center of curvature, this is the fourth type of ray which we are expected. So, this actually we have some chances. Let us undergo. Should travel positive, that is parallel? No, there is no chance like that. Should travel anti-parallel? No, it is also not a chance. Then, should it reflect? No. Then what happens? It goes for special category. It has come this way and hit the surface, convert itself into 180 degrees, then goes away in the same plane. Then goes away in the same plane. That is 90 plus 90 degrees. 180 degrees of deflection is seen here. We can expect a 180 degrees of deflection. How? The ray comes through the center of curvature in the same manner. After hitting the mirror, it just goes away. This is called as deflection to a level of 180 degrees. It has twisted to a 180 degrees. This is a fourth rule of a concave mirror. So, my dear friends, once I just would like to recall all the four rules. Rule number 1, a light ray traveling parallel converts itself into anti-parallel. A light ray traveling anti-parallel converts itself into parallel. Whereas the light ray which is passing through the pole reflect but not deflect. Whereas a light ray passing through the center of curvature definitely deflects in the same path but in opposite direction. This process is called as a deflection. Right. So, let us conclude the other part, that is nothing but rules of convex also. When you understand the rules of concave, convex diagram is very simple, but with a small difference. What is the difference? We would like to see now. Seema, now we would like to go on for the comparative analysis of concave and convex. Concave and convex, because just now I have used a word that if you understand the concave, convex is very easy. So I just would like to compare both of them. What is the difference also you can understand very clearly. So see here, now we are moving on to convex mirrors. So listen, first of all, let us take a convex mirror. We have taken a convex mirror, and of course this is nothing but the principal axis and of course we expect focus, we also expect center of curvature, and the most important, pole. Anywhere you go, pole is a midpoint of a mirror. Which mirror? Spherical mirror. This is important strategy. So what about for convex mirror? Let us take the first type of ray here. What is the first type of ray? We are able to expect this is parallel to the principal axis. The light ray which is traveling parallel to the principal axis. So what happens? Before saying the answer, I just would like to recall what happened at the concave. Listen. What happened at a concave? At the concave, the light ray has passed like this through the focus in an anti-parallel manner. But what happens here? It's not concave, it is convex. Because of this reason, it just bends in an anti-parallel. But the major difference here and here is, here the light ray bends towards the center, whereas the light ray bends away from the center. The light ray bends away from the center. Why the reason? The convex exhibit a phenomenon called as divergence. Convex exhibit a phenomenon called as a divergence, whereas concave exhibit a phenomenon called as a convergence. The light ray doesn't move away from the center, it moves towards center. This is the important difference between convex and a concave. The rest of the strategy is the same. What is that? Concave exhibit a convergence, convex exhibit a divergence. A concave, in that a parallel ray passed through the focus, moves towards, that's the inner side it passes. Whereas here moves away from the center. But the condition is satisfied. Parallel ray converted into anti-parallel. This is the first rule. A comparative understanding. Whereas let us go again for a second rule also. So listen, let us again compare the second rule of concave with that of second rule of convex. Let us understand this one. Rule 2. What is this? Pole, focus, center of curvature. Principal axis. Now, rule 2, what are we going to observe here? An anti-parallel ray we are able to expect. An anti-parallel ray. It's not a parallel ray. In the first rule, we have taken parallel ray. Here, we are able to expect a anti-parallel. Like the concave mirror, what is going to happen? Even this also, what about travels parallel to the principal axis? In this case, there is no deviation like the rule 1. In this case, the naturally anti-parallel ray travels across a what? Parallel to the principal axis. This is a rule 2 of a convex mirror. And let us understand the rule 3 of a convex mirror. So, this is a very important. What is that? Center of curvature, pole, focus, principal axis. We have taken that step. So what happens if a ray is in irradiation with the top to the center of curvature? If a ray is in irradiation to the center of curvature, what happens? What happened in the fourth rule of concave? The same process occurs here. The ray travels like the undeflected. It travels deflected phenomenon. This is the special case which we see only at the center of curvature, not at the other point. So, at the center of curvature, if any type of ray can be executed, that changes its direction but in the same path. Changes its direction but in the same path. Like, it comes like this, touches here, reflects and goes. It's only for the mirrors. So, these are the rules of ray diagrams. That's the first one is, we are able to expect a concave 4 rules, convex 3 rules. These are 7 simplified rules. You can also refer in the textbook. In the textbook, it is somewhat complicated, may cause a little amount of confusion to a normal student. Thus, we have been simplified this and making you presented the 7 rule things so that every student can understand a minute bit also. Right? So now, let us go on for important 4 marks question. It's a very important 4 marks question. What is that? Before going to that, how to write that question when a question is asked? The presentation just we see and then we go on to the case. So, what is a ray diagram? Let us understand the concept. What is actually a ray diagram? See, a ray diagram is a roughly drawn substance. A ray diagram is a roughly drawn substance. For what it is useful and what are the properties useful? Like, we have given 4 properties, that is nothing but a size. We have also given the position. We already given. What about nature? And apart from this, we come across location. These are the 4 included in your properties. So, how to draw a ray diagram? What are the steps to be followed in drawing a ray diagram? How to construct a rays? What type of nature does they occur? All the things we will be studying in the consecutive class. Don't go away. You're watching ABC Education and Learning app. Keep joining with us to obtain quality education. Thank you.